let's find an engineer, let's put one in, let's see how it runs, and let's see how productive it is, and let's see if there's, see if there's any like vandalism, all those kind of things that can come into play. Let's see how it runs. Let's see how the system holds up. Will the methane actually degrade the architecture of the system, etc. All that kind of stuff.
Yeah. True. That's a good point. All right. Thanks. Sorry for keeping you, Steve. I just wanted to mention some of those things.
No, that's great.
It's so interesting.
Wasn't planning to go anywhere.
All right. So thank you. And I hope most of you are back with us. We're going to continue with our last two presentations, starting with Janet's, also on biogas. So we have a theme, at least for these three presentations. So Vanya, I believe this is a video that we're going to be playing.
It is a presentation with recorded audio on each of the slides. So I would ask your patience to check whether this works as it should. I will basically start sharing the presentation now, and the audio should start playing immediately. But if you don't hear any audio, please let me know, okay?
Okay.
I'm Janet, and I'm presenting on biogas production from organic waste, a case of the Giacomo. Other solid waste are generated from our daily activities. And in this solid waste, we have the organic parts. These organic parts are easily broken down within reasonable amounts of time into their base compounds by microorganisms. And biogas technology is an important sustainable development. It's important for sustainable development because of their role in the renewable energy program. So more on biogas production from organic waste, using the organic waste in the community. So our problem statement, you can see the picture on my right here, that there are chunks of waste. And from investigation, these waste have been there for about 6 months. And we can see the health hazard this thing is creating. Waste are thrown away haphazardly. And this is a breeding ground for mosquitoes, breeding ground for insects. There is lots of poor sanitation in the area. It's just an eyesore. It's something that needs to resolve. And in order to remediate it, I think one of the best ways is to convert them into energy, which will be useful for the inhabitants of the community. For justification, the conversion of waste to biogas will reduce the amount of waste in addition to energy generation. And to me, biogas is a suitable alternative to address this situation because there is high rate of biomass usage as a cooking fuel in the area. And aside this biogas being used as a cooking fuel, it can also be used for lighting. So I think biogas is the best energy to be considered in the case of this community. For the study, as I said earlier, there is bad odor, there is high rate of insects, there is poor sanitation, there is high records of food and waterborne related diseases in the area, and the high usage of wood is also another factor. Based on slide questionnaires and investigations, I came up that about 15% make use of LPG, 60% use charcoal, whilst 25% use firewood. And charcoal is also derived from wood, so charcoal and firewood together will constitute biomass, and it will be about 85%. And if about 85% of people are making use of wood, and our wood are being cut down, our trees are being cut down for the purpose of cooking, carbonization will increase and climate change will increase. As we are advocating for decarbonization, these are some of the things that we also have to focus on. Is to determine the biogas potential of organic waste in the community. Of the objective, I will first determine the total amount of waste generated in the community, and this will be done by the use of the study from MISA Itel in 2015. They came up with the per capita waste of every Ghanaian, and they said every Ghanaian generates 0.47 kilogram of waste per day, and this per capita waste has been used as a baseline for all waste management programs in the country. So with this per capita waste, I multiply by the total population of the community, which is estimated to be around 2,500. And after the multiplication, we came up with 1.175 tons. So in this community, per their population, 1.175 tons of waste are generated daily. 1.175 tons of waste is approximately more than 115 trash bags, which is a lot. So annually, this community generates a waste of 429 tons, which is more than enough to generate biogas from. The biogas potential, we use a formula as used in many work from literature. So we determine the biogas potential by multiplying the total waste by the concentration of the organic fraction in the solid waste generated, and multiplying again by the total solid concentration in the organic fraction of the solid waste, and also you multiply by the biomethane potential of the organic fraction of the solid. These values were determined based from literature. The organic fraction, as we've calculated the population, the total waste already to be 429 tons, the organic fraction 64%, the total solid organic fraction taken as 541, and the biomethane potential taken as 0.32 based from literature, based on literature. So our biogas obtained will be 47,532. So the biogas potential of that particular of the chunks of waste is estimated to be 47,532, which is of good use as a fuel, as a cooking fuel, and even as a lighting. So we don't have to, these waste don't have to be a nuisance to the society, whilst we can generate this amount of biogas from them. So in view of our prototype model, and this prototype model will be connected to our cogeneration engine, that is the CHP, which is the combined heat and power engine, to supply us the heat and also the electricity. So our waste, our community waste, will be transferred into our electric shredder, and this electric shredder will do justice by breaking the waste into smaller pieces. And after the waste have been crushed down into smaller pieces, they are slurified and being moved to the preheating system. And this preheating system, the heat will be supplied by the CHP engine. This preheating system will occur at a temperature of 50 degrees Celsius. And our our co-substrate that will be used will be cattle manure. I've seen a very big cattle farm closer to the area, so we can make use of the manure coming from the cattle farms as our co-substrate, and this will be pumped into the preheating system to mix with our main substrate, that is our waste. And the use of this engine will be useful because it provides a constant heat to enable a stable digestion. That is why the main reason why we make use of this engine. So after our preheat, our substrates have been preheated, we use these pipelines to pump them into the digester. And in this digester, we have a retention time of 30 days to enable the anaerobic process to take place, after which we use a separator to separate the biogas generated and digest it. We will have a liquid fraction and also a solid fraction that can be dried and used as a fertilizer, because the community is a farming community. We can supply this solid digestate to them as a fertilizer, and the liquid fraction can also be treated and be reused again. And our biogas can, if we have enough resources, our biogas, we can upgrade it by removing these toxic chemicals like carbon dioxide and others, so that we get a clean biomethane. Is to include waste from nearby communities, because I've done a work around and I've seen that the closer communities also have chunks of waste that are not segregated, that are thrown haphazardly in the area. So including them will increase our substrate. I plan on doing something like that, and I also plan on advocating for biogas as a source of cooking fuel, because the use of wood is too much. Charcoal and firewood is too much in the area. So if you have a clean energy system like biogas, I think it will be very helpful to them and also resourceful to the country and the world at large in relation to climate change and global warming. And also have plans of partnering with, we have a waste to energy plant in Jankoba, a certain area in Ashanti region. And I've contacted them before because I wanted them to collaborate with me in my PhD research work, but due to certain circumstances, it wasn't feasible. So I'll contact them again to see whether we can partner in this project. And also, I also want to partner with some waste collection organizations for effective collection and segregation of waste in the community. I've already contacted the community waste recycling project. They recycle, they collect plastic waste and recycle them into useful materials. I've contacted the director, Mr. Seidu Salim Abubakar. I contacted him through mail. He is yet to respond. They can be useful because after they will help us in the segregation and take the plastic parts, so that we make use of the organic as part of the waste. And depending on the available funds, I want to construct something small using the prototype model. Yeah, the challenge is still there. You can contact me at janetotapia@gmail.com, and my phone number 05450721.